8.3 Reference Angles and Inverse Trig. Thank you to many of you who turned in your homework, and there were some really great ideas on how to figure out what the angles are that go with these Pythagorean pairs. So we're calling these the Pythagorean pairs because what we know is that the cosine theta squared plus sine theta squared equals 1. That makes sense because this is our circle. X squared plus y squared equals 1. So notice these are the same pair of numbers. They're just switched over the x equals y. And that's an interesting point. We know that that must yield a tangent of 1 because we decided last class that tangent was equal to y over x, which was equal to sine over cosine, which was in fact the slope of our radial line. So how can we find these angle measures? I had some great ideas. We'll just jump right to it. And I'm going to point out that if x is the cosine piece and y is the sine piece, if we look at this right here, we know that cosine theta must equal 0.5, and we've been here before. We've got the output, we need the input. That means cosine inverse of 0.5 equals theta. So go to your calculator and we're going to say cosine inverse of 0.5, and we get that that's a 60-degree angle. So if this is a 60-degree angle, the other part we learned last time is if these numbers are switched, this must be a 60, 30, 90. So that means this angle measure that takes us to 0.866 must be a 30-degree angle. And let's find one more. Why don't we do sine this time? Sine theta equals 0.707. That means sine inverse of 0.707 equals theta. We'll come over here to our calculators. Nope, do I have a mouse? And do sine inverse of 0.707. We'll round to the nearest degree and we get a 45 degrees. So this angle in the middle must be 45 degrees. Well, now this lesson we're going to use our reference angles to find where those numbers must happen in the other quadrants. So let's start with these, what I'll call the green ones, the 45-degree angles. To get into this quadrant, we need to take 180 minus our reference angle. So that puts us over here at negative 0.707, positive 0.707, and that's going to happen at 135 degrees. We'll look at our red reference angle. That was 60. When we take 180 minus 60, we're going to be at 120 degrees. So right there at 120 degrees, we're going to be at negative 0.5, 0.866, and that's going to be 120 degrees. We'll look at our blue one. It's a 30-degree reference angle. That's going to put us right here at negative 0.866, 0.5, and 180 minus 30, that's going to be at 150 degrees. Let's go through all the green ones. Down in this quadrant, we need to be at 180 plus theta. 180 plus 45, that's going to put us here at 225. And over here, we're going to be at 360 minus theta. So 360 minus 45 is going to put us at 315 degrees. Let's go to the 30 ones. 180 plus 30, that's going to put us at 210. 360 minus 30, that's going to put us at 330. For the red one, 180 plus 60 is going to put us here at 240. And 360 minus theta is going to put us here at 300 degrees. This is kind of a preview. You are actually going to do this as your 8.3 homework B, and that's a preparation for the next class on April 14th. So you want to get very used to seeing these numbers. These numbers are going to come up over and over again. Not only the degree measures, but also these particular Pythagorean partners. So let's get on to the work of today. Here's the problem though. We're going to need to outsmart our calculators, because our calculator gives us the wrong answer if we were to put in sine theta equals 0.77. It's going to give us a theta in the first quadrant. And we know that's not where we want to be. So we're going to, just to make this very quick, we'll try to have an opportunity to talk in person, I hope, to give you the subtleties of why this happens. But because your calculator gives you the wrong answer it's different for sine and cosine and tangent, but we're going to say it gives you the wrong answer as a rule of thumb unless you're in the first quadrant. So your calculator will always give you the right answer as long as you ask it to do a first quadrant. So we're going to always say this. This will give us if we put in a positive, so for any trig function, either sine theta or cosine theta, you're going to look at the absolute value of what it is in order to find the angle measure, because then that will always yield a first quadrant reference angle. And then you can use your common sense to figure out what that angle ought to be. So let's try this. I'm going to do the cosine one. So the absolute value of negative 0.64 is 0.64. So I'm going to come over to my calculator and I'm going to say cosine inverse of 0.64. And it gives me 50 degrees. We're just going to round to the nearest degree. So if my first quadrant theta is 50 degrees, that means the angle that I want is 180 minus 50. So what I really want is 130 degrees. That's the solution on how to find the angle measure. So here's your little procedure. Always use cosine or sine inverse of the absolute value, and then use your reference angle to find the correct one. Over here, we can choose, why don't we do sine inverse of the absolute value of negative 0.841. Our calculator then will give us sine inverse of 0.841, which is the absolute value, and it gives us 57 degrees. So that's our reference angle. But we're in the third quadrant. So to be in the third quadrant, we need to take 180 plus 57. So that's going to put us at 237 degrees. How about over here? We could do either the sine or the cosine. We're going to take cosine inverse of the absolute value of 0.9. Absolute value of 0.9 is just 0.9, obviously. So cosine inverse 0.9. We get, call it 26 degrees. We're in the fourth quadrant, so we need to take 360 minus 26. So that puts us at 334 degrees. So if these are all of our locations, we're going to do the same procedure. We know this one's in quad 1, so you should probably identify which quadrant you're in right away. Here we're in quad 2, here we're in quad 3, here we're in quad 4. Finding the slope of the radial line every single time is just taking y over x. And the video is getting a little long, so I'm just going to leave that for you to do. So that would make our slope positive in quad 1. That would make our slope negative in quad 2. That would make our slope positive in quad 3, and it'll make our slope negative in quad 4. To find the angle measure at each of these, we can take either one. We'll just do a couple of them. In quad 1, if we take, oops, I already forgot the cosine inverse of 0.208. And we get 78 degrees. Oops. And we're at 78 degrees. And we're in quad 1, so that's already the right answer. In quad 2, well, we're just going to do quad 4. We're going to run out of time. I'm sorry this got so long. In quad 4, calculator, shoot. Where were we? 0.809. We'll do cosine inverse again. In quad 4, we're at cosine inverse of 0.809. And we're at 36 degrees. So if our angle, our reference angle is 36 degrees, we're going to take 360 minus 36, and we're going to be at 324 degrees. I think I better skip to the last part. I'll put a key on line. And the last part, find the missing y value. We can do that by taking 0.961 squared plus y squared equals 1. And we know we're going to want the positive y. The angle of rotation, we can find that by taking cosine inverse of 0.961. And the slope of the radial line, we're going to take y over x. Oh, the equation of the tangent line to the circle at the point, we're into some thinking questions. If this is the slope of the radial line, we can recall that the tangent line is going to be perpendicular to that. So the slope of our tangent line is going to be negative x over y. And